So a decade back, everyone jumped onto the bandwagon of this whole big data, right? Like building large analytical repositories. Every database company, you name it, from IBM to Oracle to every single database company, they were like building their own analytical warehouses. Now, with this whole data explosion, right? What we are seeing is there's a reverse trend happening. People are, especially with the higher TCO, with the compute needs, and every time you have to go to the procurement. So, there is a reverse trend happening, and with the new cloud native analytical repositories coming into the picture, people are trying to get their workloads into these cloud native repositories, analytical repository, and like Azure, GCP, and so on. Single store is one of those. Snowflake is another one of those, right? So we see there is a reverse trend happening, but there is a problem, right? Like getting away from Hadoop, is not that easy. Like there's a petabytes of a data sitting out there. And that is the challenge, and that is a problem what Zapper solves, right? So we built the world's first data moment solution, which primarily takes care of all this and moving it from the Hadoop to the relational repositories, columnar analytical repositories. And that's primarily what we are going to talk today. And I am going to hand it over to Niti, to primarily bring in the right set of folks onto this webinar to showcase you how we are solving this problem, how are we going to help whether it is the Cloudera customers or any Hadoop customers who are facing the same challenges. They can resonate to this problem, and we are there in order to support them. And that is what we stand for. And with that I'll hand it over to Niti and Shubhu, who's on this webinar. So over to you, Niti. Thank you.
Thank
and
you
I'll
so
be there
much,
for the
Param.
rest of the call. Yeah, thank you.
Thank you, Javier, and thank you, Param. Javier, can somebody bring up the pages?
Sure.
So while we wait to bring up the pages, hello, everybody. Thank you for joining this webinar. I think Param has set up the whole context and the introduction for this webinar really nicely. So I'm going to jump straight into it. I'm sorry, my Spanish doesn't go beyond a few words. So I'm going to be speaking in English, and I hope all of you can follow through. Yeah, so very quickly, what we are going to talk about today is we'll talk very briefly about, the rise of Hadoop and big data, and what are the challenges that companies who are heavily invested in Hadoop are facing today, and why migrating out of Hadoop today makes good business sense for businesses. And then Param talked about the whole data movement platform that we've created. So we're going to talk about what's unique, what are the features, benefits, what we promise, what we can deliver. And then Shubho will be joining us. I believe he's having some connectivity issues because he's traveling, but he will join us in a few moments. And then Saptarshi is on. He's going to show you a real live working demo of what we've built. And then we can have a question and answer session. So with that, let's move to the next slide, please. Yeah. So as Param was also referring to, about 15 years back, this whole notion and movement around big data started. And the first thing that really happened was in the early 2000s, the Nudge open source project was launched. It was in 2005, they launched the distributed file system, which was based on the Google file system and MapReduce. And alongside, there was this, whole concept of big data. There were, people talking about big data almost as a natural resource. People said big data is the new oil. The IBM CEO famously said that, data is the new gold, and, we're going to be investing a lot of our resources into exploring and discovering insights from this big data. There was this whole investment community, which, was very excited about this. Yahoo experimented and hardened sort of the whole, Hadoop and big data projects. And then in 2008, I think Cloudera became the first dedicated Hadoop company, followed by MapReduce and Hortonworks. I think everybody sort of recognizes these names in the Hadoop ecosystem. And what was, really fueling the rise of Hadoop and the things that, companies and the ecosystem really went after was that Hadoop had the ability to store and process huge amounts of any kind of data. It had huge computing power, very high fault tolerance, and very high flexibility. Flexibility in the sense that it didn't, need to process any data. It didn't sort of screen any data. You could store as much data as you want, unstructured text, images, decide how to use it later. It was, low cost for storing that amount of huge data. So, the whole sort of ecosystem was putting its weight behind, the notion of big data and how Hadoop was going to sort of empower that and, bring that to life. And Hadoop and big data actually became quite synonymous. Everybody who was going after a big data strategy was looking at implementing Hadoop-based data lakes. And, the notion that Hadoop was free also accelerated and amplified this phenomenon. And, it was in the Apache ecosystem. So all of that happened. Next slide, please. Unfortunately, there was very quickly a reality check that happened. While Hadoop provided an economical platform for big data storage, it became very clear that Hadoop provided very little in the way of analytic capabilities. It could not really scale to provide real-time analytics. So while there was this whole explosion of data, I mean, companies were producing petabytes and zettabytes of data and looking to harness insights from there, Hadoop could not really scale because Hadoop was mainly batch processing, no interaction with the user. It could not handle stream processing. It could not produce output in real time with low latency, which is what all enterprises really expected. It didn't have a high degree of concurrency, couldn't operate at speed. And so, the whole notion of data lake degenerated into data swarm. And Hadoop is now being given the nickname of data jail because your data is there, but it's very difficult to get insights. Additionally, what happened was there was a lot of complexity around operating these Hadoop clusters. You required a lot of specific skills, and those skills started becoming scarce. So the whole economic data storage did not really keep pace with the economics of analytics and maintenance. So while modern applications and modern enterprises needed very fast ingestion, ability to handle streaming data, very high concurrency with ability to manage high volume of concurrent transactions, and at the same time, very fast and real-time analytics, Hadoop was getting constrained around all of these. Performance was not scaling. There was a lot of complexity in operating these clusters. The architecture was becoming very brittle. And the whole concept of data federation, sharing data across the enterprise, and different analytical applications being able to use that data was not coming to life at all. And of course, the costs are becoming more and more prohibitive. So really, Hadoop is not being able to today serve the needs, analytical needs of enterprises and the realities of modern applications. Next slide, please. So, again, Param alluded to this. We are now seeing the emergence of, new age, new generation of relational databases called new SQL. and they address the speed and scale issues that previous generations of databases have suffered from. So they provide speed, scale, they are cloud native, available available across different clouds, available at speed, available at economy. So a lot of now enterprises are looking at how do they move their data and workloads to these new databases. Next slide, please. And what is it that these new databases are promising, contrasted with what the problems with Hadoop are? They are providing faster and more comprehensive analytics with complete data federation. The data is available across the enterprise, and the speed of delivering data is improved by factors of 200x to 5 times that. The architectures have become very, very simple. You don't need any specific skill sets. You don't need a captive set of engineers sitting there to manage your architecture. These databases scale. They are very resilient, fault tolerant, and also they are proving to be cheaper than Hadoop by almost half. So you have the opportunity to really reduce your Hadoop operating costs by half or even more. And they serve a whole variety of use cases through the whole concept of data federation. So these are the reasons why new age databases contrasted with Hadoop are really proving to be tailored to the needs of modern applications and modern enterprises. Next slide. Was Shubho able to join? I don't see him on. So I'm going to keep going, and I hope he's able to join. Okay, looks like he's having problems with Zoom. So we'll continue. That's not an issue. So, we've explained in the first section of the content why Hadoop is a challenge and why businesses are now looking to migrate out of Hadoop. In this section, we are now going to talk about the whole problem of data migration and how we are approaching data migration. So when we look at, migrating data from Hadoop to, say, another target database, we are not just looking at, picking up data from one source and, putting it in another target. We have looked at the problem holistically, and we are saying when you approach, we are looking at data migration in terms of having a particular business have complete business continuity while they migrate their data. And database migration is not just about, like I said, just migrating data. It's about understanding schemas. It's about making sure those schemas are migrated seamlessly onto your target database. It's about migrating the actual data while maintaining business continuity, and then migrating the whole set of applications. Those could be your analytical and read-only applications, as well as your transactional applications. So we are viewing the whole sort of aspect of database migration from that lens, not just taking data from one source to the other source, but really looking at it holistically. And that's how that has fed into how we've designed our platform and what our platform does. And how we want enterprises, also our clients and customers, to approach the problem of database migration, in terms of partnering with them to make sure that they have complete business continuity in the journey of migration. Next slide. So I'll briefly touch upon the data migration lifecycle. Again, looking at complete migration of the business data and business applications, and ensuring that businesses have complete continuity. So the migration lifecycle, the way we see it, is really divided into 4 phases. The first phase is the design phase or the discovery phase, where we look at discovering the source schema. We work on designing the target schema, and then allowing mapping between the source schema and the target schema. And we allow those, we enable users to sort of make changes so that the target schema really is, usable, and you can make whatever changes you need in the target schema and not really persist any design flaws or any business needs, etc., that need to change, making sure that, we allow that flexibility and we don't persist any flaws in the source schema. The second phase of the data migration is about doing an initial data load, where we take a snapshot of the existing data, and then we start migrating that data into the target database. And then the third phase is about making sure that while the snapshot migration is going on, we have a CDC pipeline, which allows you to continuously replicate data as your transactional systems are generating that data, making sure that while the snapshot migration is on, the CDC sync is also seamlessly replicating data, and there is no sort of break in data continuity or data replication. Now, after the sync pipeline is established, that is where the application migration lifecycle is complete. And, you make sure that you also migrate your applications, your transactional applications and your analytical applications, which will require you to refactor your analytics and your transactional applications from the source databases to the target databases. Once that is done, in the fourth phase is the retire phase, where you can actually retire your source data store, which is Hadoop in this case. Once you retire that source database or the Hadoop file system, that's when the final stage in the data migration is complete. Next slide. So in order to support the data migration lifecycle, the design phase, the sync phase, this one-time snapshot phase, we've developed modular capabilities within our data migration platform. So essentially, it has three elements. The first is the migration designer, which allows you to discover the source schemas, and we support a whole variety of source schemas. Seamlessly map that to the target schema, and you can define your column mappings and data type translations. I alluded to that, and you will also see that in the demo. Saptarshi will show how we discover the source schemas and design the target schema. So this is the migration designer component. The next one is the snapshot loader. What it does is it does automated data loading from snapshots that are taken point in time. This is a one-time data migration, which helps to seed the target data store and get it ready for continuous data replication. And the one thing about this snapshot loader is that it's horizontally scalable and manages very high volume data loads, which is anyway a reality with Hadoop. And it supports multiple data schemas and file types such as Parquet, Abro, and ORC. And then finally, in the sync and retire phases, we use the CDC engine, which is about continuous replication, which keeps the source and target data source in sync in near real time. It also comes with embedded data quality checks. It supports multiple relational and NoSQL databases and Hadoop file types. And it also enables CDC-based integration of source systems to data lake platforms. So in a sense, these three capabilities is what forms our data migration platform. And this is the demo that you will see. Our contention is that this is an industry first. Can we move to the next slide, please? We support all kinds of databases. It has a UI for schema mapping and designing your target schema, and also setting up of the pipelines and monitoring the progress, etc. So we believe that this is an industry first, and also we support all of the leading industry database platforms. This kind of generalist approach to data migration, especially from Hadoop to the new age databases, is a capability that has not been built in the industry so far. and it can resonate, and it will resonate with a lot of enterprises and database companies. In addition, what our platform offers is it is magnitudes faster than manual migration. It offers 100% data consistency. I talked about automated data quality checks, and it is at least 10x cheaper than manual migrations, which is what most of the consulting and services firms are doing today. Manual migrations, again, error prone. They require a lot of time and effort and investment from people, and they do not guarantee the sort of business continuity that automated efforts like this promise. Next slide, please. So, this is again an indicative list of the source and target platforms that we support. It includes most of the new age databases that most companies are looking to explore, especially to meet needs around real-time analytics. So we support all of these leading databases. Next slide. The next two slides is basically a quick view of how a migration journey might look like. As far as we see it in terms of business continuity and not really making very, very drastic changes, which might be difficult for enterprises to deal with. We are looking at migration in two phases. In the first phase, we do the one-time snapshot migration and set up the CDC data replication engine, which allows you to start moving the data from Hadoop to a target data store of your choice. This will ensure that you're migrating your historical data, as well as keeping all of your business applications in sync in near real time. Post this phase one migration, while the source applications will continue to funnel data through Hadoop, all of the workloads will run on the new target database. So essentially, there is no data processing which is really happening on Hadoop, but the data is still getting funneled through Hadoop. And at this point, enterprises will start to realize value in terms of reduction of costs in their Hadoop clusters, because all of the processing can now happen on the new data stores, while the CDC replication engine ensures that data is continuing to flow and there is no loss of data. Next slide, please. Once this is done, in the next phase is when companies can really look to do a complete Hadoop takeout, at which point all of the analytical and real-time applications are rewritten to point to the target database, and there is no dependency on Hadoop. So the Hadoop ecosystem can be completely shut down. The sync or the CDC engine continues to replicate data from the applications to the target data store. And this is the point where you can say, your entire sort of business data migration is complete. So, this is in very short, our submission in terms of why Hadoop, what is it that we've built, why it's different, why it solves the problem of, business continuity, faster, cheaper, guaranteed, better, and how a migration in a business context will actually look like. I will now hand it over to Saptarshi, so he can take us through the demo, and then we can jump into a question and answer session.
Thank you, Niti.
Hi, everyone. Yeah, Javier. Myself, Saptarshi, and I lead the engineering for the data platform at Sapper. And today I will demo you how we can create a snapshot pipeline, how we can create a pipeline from Hadoop to single store. So let's get started with that. I'll just start with sharing my screen. Javier, would you please enable me to share the screen?
Sure. Pueden hacer que comparta la pantalla su laptop, por favor. Listo. It's ready.
Thank you so much. Okay, hope you were able to see my screen now.
Yeah, sure. Yes.
Okay. So even before I start, I'll just show you. Okay, so this is the Sapper UI. We are at the login page. We have a single store set up here where, I mean, this is the dashboard. And then we have the Hadoop system. And you can see that this is one of the directories where we have a bunch of subdirectories having all the data in there. And even before I come to this, I'll just show you that this is all the data. I mean, this is the data that we have in Hadoop, and we will just try to create a pipeline to migrate this data. I mean, one of the tables. And also I'd show you how it looks when we have the data referenced in Hive. So yeah, the same system. So you can see these are the tables, the option table, and all of those under demo. And if you look at this, this is also demo, and you have the option and stuff, option and other tables. So inside option, if you go in, you can see the different directories, and these are the partitions basically which holds the Parquet files. And as part of the demo, I'd show you how we can actually create the schema on a single store, how we can actually reference each of these files, and all the data is actually shipped from the Hadoop system onto single store. Okay, so let's get started. Let me start by logging in first. So once the user logs into Sapper, you'll end up on the pipelines page where you can see a bunch of pipelines here, and they're in different states now. So people have created pipelines. So you can see some of them are running. One of them is in pause state, right? Some in review, waiting for a review, right? So I'll just talk about all of those in a while. This is a paginated UI, so there's hundreds of pipelines, tons of pipelines out there. Okay, let's get started now by creating a pipeline. So I click on create, and I actually create a demo pipeline now. I name this as a pipeline demo, and you can see, as Niti was referencing to, we support a bunch of applications here, but today we are interested in Hive, so I go ahead and select Hive and as the source, and for target it's single store. So both the source and the target applications are selected, and I go ahead and create the pipeline. So now the pipeline is created, and this UI actually tells me about the different connections that's created. But I mean, by connections, what I mean here is the connections to the Hive databases. So there are a bunch of Hive databases out there, and these are all being tried. So I'm interested in a particular one, which is the Hive QA instance, and this is the same instance that I was talking of. This is the Hive QA. So I just go there, and you can also add a new connection from this page as well. So yeah, this is the Hive QA instance. I click on next, and this is actually the discovery that we were talking of. So when I click on next, I get to see all the different databases or schemas that's created in Hive. I expand one of this, and I can see the whole list of tables here, which was created. So today, as part of the demo, I would actually select option table, and I'll try to create a pipeline using that show the data getting transferred over from Hive to single store. I click on apply. Once the source connection is decided, and then we decide on the tables what we want, I now go and select the destination connection. That is one of the single store instances that we have. And this is the single store instances in AWS. So I click on next. This gives me a preview of what has been selected for migration. Today, it's only one, but yes, you can have a bunch of tables and databases here. I go ahead and click on apply, and which takes me to the mapping screen. And as Niti mentioned, actually, you can hear, this is the designer, right? The schema designer. So you can actually see the source schema. These are the source fields, actually, the ask price, this, that, and all the different data types, flow, teams, and all. So what we do here is we create the target schema, right? Using the same mappings. We retain the mappings wherever possible, but then yes, the user can go ahead and also change the target table name if they want. You can change the database name. You can go ahead and change the data type if you want. You can even go ahead and change the column name if you want, or you can actually map one column to the other one. So all of those things is possible. Also, I'll show you what this constraint is doing here. So this actually is something which is very specific to single store. And as you know, that single store actually allows creating the primary keys and the sort keys and the shard keys. And then you can actually have a bunch of columns in a sequence for a primary key or a sort key. And these UI actually allows you to do that. So you can see that this is index 1. So if index 1, I can actually add a X ask price. And then in index 2, I can add something else, right? So this actually helps me to create multiple primary keys, and that too in a particular sequence. So this is very specific to single store requirements. And this actually is for making your queries very fast, right? So one of the capabilities of single store. So yeah, so now let's say that we are all set. We are done with the mapping. We have mapped. We are sure that this is the column in the the field that goes into from the source to the target. And if you can see here, this is the stock ID. If you remember the stock ID. So if you remember the stock ID, that's actually the partition. So it tells me that this is the partition one. So these are all the different partitions, right? So this it's partitioned by stock ID. So so once we are all set with the schema mapping, we can even go and view the DDL actually that would be used to apply on single store. So this is the DDL actually that would get that would be applied on the single store instance, so that the schema and the table is prepared, right? So you can go and make your changes and come here and validate that. That's a flexibility actually that we provide. So before we start with the pipeline, we have to we have to go and initialize. And what initialize means here is I go and create the target database and the table. So you can see that there is no option table here. It's only an employee with some 50-odd rows records sitting there. So I go and click on initialize, and now it tells me that the pipeline is ready to be executed. And let's go here and just do a refresh. And you can see that option table is created, right? And this option table has all the different fields that you have selected in Sapper UI. Okay, so let's go back to databases demo, and yeah, so let's be here for a bit, and let's go ahead and start the pipeline. And so now the pipeline is in the ready state. That tells me that you can go ahead and trigger the pipeline. So let's start the pipeline. So I have started the pipeline, and this is the UI that I get, where it shows me this is the table and which is in running state. It shows me the source, the target, and the connections that has been used. You can go ahead and pause the pipeline if you want. right? So let's go here and try to see if data is already started coming in, and we can see data is coming in, right? So we can see that some 917,000 records have already started coming in, and you'll see that this will so it's 1.84 million records. So yeah, so what we are doing here is we are taking these files, reading the files, we are bringing in over, right? Taking the records from it and pushing the records onto single store. Okay, so yeah, so we can even refresh this page to see the number of records that we have on the source and the target. We can see that the row count is increasing. Now we have around 3.34 million records that has come into single store. You can have a look at the sample data that is there in there. We have around 6.12 million records, and I think that's the max, I think, what we have here. And you can see, yeah, so I mean this currently needs a refresh that we need to do. Let me see if there is any more record. Okay, yeah, it's still increasing, right? So 7.19 million records have actually come from the source onto the target system. This yeah, so I mean all the different Parquet files would be read, and it would actually bring the data in here. Let's see if we have.
Time is getting to the end, so if you want to give a final message, Param, and then I will close with a translation of that.
Yeah, sure. First of again, like we thank the audience. We really appreciate like your time. I know like it's a busy day, right? Still Thursday, so it's a busy week, and we appreciate it. The entire team of Sapper, we appreciate it very well. And to the LAT-BC team, Javier, and like the rest of the team, thank you for putting it together. We are there to support in the journey of like your being Hadoop customer, right? And moving and looking at like other alternatives, like for helping your businesses, helping your helping like your end customers in order to gain the real-time insights, which is like what like every enterprise customer is looking at this point of a time, right? To have that stickiness like with you, what you are serving it as a product to your end customers, to your business owners and so on. So I think the world is moving into that direction where like like people are making decisions on real time, right? And we enable that, and we are very excited about this like entire journey. Like we live in the data space, we live and breathe that like a data. So we will be there to support you in your journey of transitioning or looking for alternatives for all these different like real-time insights. And we are there like even after this call, like if you have questions, anything, please feel free to reach out to us. I will hand it over to Niti for the closing remarks as well. Niti.
Yeah, no, I think Param, you covered it. Firstly, thank you for giving us the opportunity. I think as a team and as an organization and as a company, we are really confident of the vision and the value that we can deliver to companies such as yours, and also to our end users and clients. This whole vision and this whole effort and this whole piece of technology that Saptarshi and team have built is based on a lot of sort of thinking and empathy and a lot of passion. Param and Shubho and, a lot of us have worked very closely, engaged and understanding what are the challenges that, modern enterprises are dealing with. And the way we've approached the design of this whole platform and the way we've built it is really, very holistic. That's what we really believe that the whole solution is very holistic. It's based on a lot of empathetic design and understanding of business challenges. And, we are very passionate and excited about the value that we can deliver. So, if we can partner and we can, take this solution to our end customers, I think all of us will win in that journey.
Thank you. Thank you very much, Param, Niti, Shabu, and all the support team to supporting this webinar. Gracias a todos en nombre de la ADBC y en nombre de todo el equipo de la ADBC. Les queremos agradecer su tiempo. Estamos seguros que esto va a transformar toda la estructura de datos y el problema actual que tenemos con Hadoop, siendo nosotros los precursores de Hadoop hace ya 8 o 9 años. Estamos un paso adelante y les vamos a traer algo de mucho valor para seguir hacia su analítica en tiempo real, o analítica avanzada, o analítica embebida, ¿no? Gracias por acompañarnos. Les deseamos que tengan un buen día. Pronto los contactaremos, les haremos llegar esta información a todos los que se pudieron conectar con nosotros y pronto los contactaremos si quieren más detalles. Muchas gracias a todos por participar. Saludos.
Muchas gracias. Buen día.
Thank you. Bye-bye.